Hi everybody, I'm Caroline Richardson and welcome back to Make the Grade. This is our last show this semester to help you get ready for the EOCs. If you don't have the practice problems already and you still have yet to take the EOC, I need you to go to the Wake County website at www.wcpss.net and look at the very top and the very bottom and you'll see a banner about Make the Grade. Click on that and it'll take you to some Adobe files that'll have all the problems listed out for Algebra 1, Geometry, and Algebra 2. And it'll also have a success series, which is some videos of some of the different lessons. So if you get stuck on something, say you can't remember how to do logarithms, you can go to the Algebra 2 success series, find the lesson on logarithms, and review it so you're ready for your test. Okay? What I'm going to focus on today, at the beginning of today, is Algebra 2. And then if we have time at the end, I'm going to do a few more Algebra 1 problems and geometry problems. Okay? So let's get started. Last week I'd already done problem 1 and 2. And I just want to remind everyone with this logarithm problem that I certainly didn't do this in very mathy terms for you. I just wanted you to see the pattern put together. And you need to remember, you're not going to have these formulas on the test anymore, so you really need to remember that the log base of the answer, the solution, is equal to the exponent. That's the exponential, or that's the logarithmic form. Okay? The exponential form would be that the answer is equal to the base of the exponent. Okay? So that way, this is how you're going to make those conversions. And you need to, let me just get that out of the way, you need to be sure that you've memorized that pattern so when you have a logarithm problem, you can do that conversion. All right? All right, let me just go ahead and start with problem 3. What are the values of x and y when 3 minus 2i minus x plus yi equals 2 minus 3i? All right, how are we going to approach this problem? Well, you need to treat the I just like a variable at this point. And then at the very end, what are you going to do with it? Well, what does little baby I represent? Little baby I represents imaginary numbers, okay? So at the very end, I'm going to show you an imaginary number wheel, if you will, to help us translate these values. So the first thing I'm going to do is I'm going to take, and let me get a blank piece of paper. So I have some room to write for you. All right. I'm going to take 3 plus negative 2i, that's coming from this parenthesis, and I'm going to take the negative sign and distribute it in. In fact, let me just rewrite the problem here. There we go. Okay? So, as a 3 minus 2i, and I'm going to take this minus sign, I'm going to distribute it into the second parenthesis. So that would be minus x plus, minus, oh my goodness, we've got to get going today. Minus yi equals 2 minus 3i. Okay? Now, if we look at this problem, what I really want you to do is try to figure out what's going to make this work. Okay? So if we look at combine our similar terms, I've got myself all messed up here. We're going to try this again. Welcome to Make the Grade. Take 2. Let's look at this problem, because I keep writing everything down not the way I want to write it down. All right. We're going to do problem 3. Here's problem 3. See, and I dropped my cap again, just on cue. So 3 minus 2i minus x plus yi is equal to 2 minus 3i. All right, and our goal is to figure out what is x and what is I. Okay? So I'm going to distribute the negative sign. 3 minus 2i minus x plus, minus yi is equal to 2 minus 3i. What we need to do is combine our similar terms. So the 3, and I'm going to bring the minus x over here, and I'm just going to kind of rearrange things. Minus 2i plus yi equals 2 minus 3i. Minus yi. I do not know why I don't want to bring that minus sign down. And you know what it is? It's because I want to do plus and negative. That's exactly what I'm going to do. So, and that's just a note to, just a reminder to yourself, of all the numbers that are out there, the most evil number has got to be negative 1, okay? Whenever the negative gets involved, whenever the subtraction sign gets involved, and how long have I been doing math? Well, you don't know, and I'm not going to really tell you, but that negative sign still will mess you up. So always just put a little flag up, put something up to remind you that that negative sign is there, okay? So what I want to do is, instead of trying to solve for something, what I want to do is say that this 3 minus x is going to be equal to this 2, and that the minus 2i plus a negative yi is equal to this 3i. What type of number is this? Well, this is a complex number. Complex number is a combination of a real and an imaginary number. So what are we going to do? We're going to figure out what the real portion is, and we're going to figure out what the imaginary portion is. Okay, so 3 minus x is going to be equal to the real portion, which is 2. So if we subtract 3 from both sides, we're going to let negative x equals negative 1. So x equals 1. And then we're going to take our imaginary portion, negative 2i minus yi, and that is going to be equal to our imaginary portion, which is negative 3i. So negative 2i minus some magical I. Well, you can still do the algebra. Just like I said, pretend the I is just a variable, so we're going to add 2i to both sides. We're left with negative yi is equal to negative 1i. So we're going to divide by negative 1, so y, well, we'll divide by negative 1i just so everything cancels out. Negative 1i. And we're left with y equals 1. Okay? And if we come back up to our solutions, the solution would be D, x equals 1 and y equals 1. Now, if you get stuck and you're not quite sure what's happening here, you need to, you could also plug and chug. You could take your values from A, B, and C and plug them in and see what works. The key to this one is you're not really solving like a normal equation where you have everything lined up and you balance it, or you're looking at it as two variables and how should I solve that? I don't have a system. It's almost just kind of a make it work sort of problem. So you're working one side just to make it match and look like the other side. You're going to see a lot of problems like that on the SAT where they want you to analyze a little bit more, not solve for it, but figure out what it needs to be to make it match. Okay? All right. Let's look at number 4. Number 4 is also dealing with the complex numbers. And I'm going to rewrite this one. So 1 plus 2i divided by 2 minus 3i. All right, when we do division, or we do these problems, you have to remember how to simplify. Simplifying a fraction can be a matter of just dividing. So look, we have i's. We can just cancel those out, right? No! Okay? These are families. You can't break up a family. I told you this before. You don't break up a family. Don't ever do that. That is purely trying to trick you. So 1 over 2i, 2 minus 3i. Okay? How would you simplify that? Well, you might say you already think it's simplified, but what does the I represent? The I represents the square root of negative 1. And one of the rules we have is that we're not allowed to have a radical in the denominator. Why? Because we don't have it that way. If you think of it, that wasn't a real good explanation for you, but would you leave an answer, because I said so, would you leave an answer as 2/4? No, the answer is 1/2. Now 2/4 isn't exactly wrong, it's just not completely right, okay? So mathematicians, when everything's simplified, one of the things that we simplify is radicals in the denominator. So remember that that's a radical in the denominator. All right, well, how are you going to, how are you going to eliminate a radical in the denominator? Well, one of the things you could do if it was a simple problem like 1 divided by the square root of 2, you would multiply the numerator and denominator by the square root of 2. Actually, what you're multiplying by is 1. You're only allowed to add 0 or multiply by 1 for any number. So we multiply by 1. Our 1 just happens to look like the square root of 2 over 2. All right, well, that works out fine for this, but what's going on here? Well, you need to remember some of your factoring and kind of work backwards, and you need to remember a word known as conjugates. If I have A plus B, its conjugate is A minus B. Where have you seen that pattern before? Okay? You've seen that pattern. Actually, let me get a cleaner sheet of paper over here. If I have A minus B times A plus B, you've seen that pattern with the difference of two perfect squares. If I was to FOIL this out and multiply it, I would be left with A squared minus B squared. Okay? Did I hit a button? Okay. So you'd be left with A squared minus B squared. You need to remember this pattern because what does this do? This eliminates the center term. All right, so over here with our original problem, 1 plus 2i divided by 2 minus 3i, the only way we're going to eliminate the radical when we FOIL it out is to multiply the numerator and denominator by the conjugate of this denominator. So remember your families. Put those parentheses around it so you don't lose it. Now we're going to multiply it by 2 minus 3i, or 2 plus 3i rather, and 2 plus 3i. And isn't that just 1? Yes, so I haven't broken any math rules because I'm just multiplying by 1. It just happens to be a very ugly looking one, doesn't it? All right, so now if we go ahead and do that multiplication, this top part is FOIL, this bottom part is FOIL. Now, before I do this, take a second. Oh my gosh, I'm running out of time. What will I do? Well, notice that there are several different choices going on here, but the key, one of the keys could be to do the simplest part of the problem. Simplest part of the problem is going to be the denominator. We have a 7, a 13, a 7, and this one would be, say, over 1. So if we simplify the denominator and it works out to be a 13, we're actually just done with the problem. We don't have to go any further. If it works out to be a 7, then we might have to do a little bit more work. And if it works out to be a 1, then we certainly can choose option D. The reason I say choose the denominator first is because you already know that pattern. You don't have to take the time to keep going with this distributive property, or the FOIL method up here. So we know that when you multiply conjugates, it's the difference of two perfect squares, right? So we're going to take the first term and square it, which is 4. We're going to take the second term and square it, which is negative 3i squared. And what does that mean? That's 4 minus 9i squared. Oh, well, that doesn't look like it got any better. Yes, it does, because what do you need to do? You need to remember what your imaginary numbers mean. All right, so let's remember them. I is just I, or you can think of it as the square root of negative 1. I squared. Square root of negative 1 times the square root of negative 1 is what? Negative 1. Oops. If I keep going, I cubed. Square root of negative 1 times the square root of negative 1 times the square root of negative 1 is negative 1 times the square root of negative 1, which is negative I. Keep going on my wheel. I to the 4th power, well, that would be square root of negative 1 times negative 1, which is negative 1, times the square root of negative 1 times negative 1, which is negative 1. So that's 1. And then we're back around. Now I'm going to come back to this little wheel in a second because this is very, very handy for you to remember. So over here we have an I squared. So I squared is equivalent to negative 1. So we need to keep simplifying. So 4 minus 9 times negative 1 would be 4 minus negative 9, or 4 plus, which is 13. Ha-ha, look at that. Okay, it worked out. So all I only have to worry about is B. Now you certainly can go back and FOIL the top to be sure that you get the same answer. And again, the one thing you're going to have to remember, 1 plus 2i times 2 plus 3i, is you're going to have to remember that I squared at the very end. Treat the imaginary number I just like a variable at the beginning. Treat it like it was an x or a y or a z or whatever it happens to be. So 1 times 2 is 2. 1 times 3i is 3i. 2i times 2 would be 4i. And 2i times 3i would be 6i squared. Combine our similar terms. There's our 3i and a 4i. 3i's here and 4i's here. Put them all together. You got 7i's. Haha. It's kind of funny. Okay. And then you have a 2 and then 6i squared. What are we going to do with that? Well, remember the wheel. I squared is equivalent to negative 1. So that's 6 times negative 1, which is negative 6. Now we can combine our like terms. So 2 minus 6 would be negative 4 plus 7i. And sure enough, that's our numerator. Okay? But one of the things we, just in terms of saving time, I focused on that denominator first, and I was able to eliminate the answers immediately for what I needed. Okay? So sometimes, especially on a multiple choice test, and of course I want you to know the mathematics, I want you to know how to do it, but we are talking about taking this test too. So aside from being sure that you can certainly FOIL with complex numbers, try to find ways to eliminate answers as soon as possible and speed up your process by doing the easier parts first. Okay. All right, let's look at another one. Simplify 1 over x plus 1 over 1 over x minus 1. Okay, that looks scary too. It's not scary. It's really, if we analyze it, it's a complex fraction. That's okay. What's a complex fraction? Well, if we go back a little bit and just write a simple complex fraction, say something like 2/3 divided by 5/6, okay? The math has not changed, just the numbers have changed, so that's okay. So what would you have done here? Well, I'm going to keep coming back. And whenever you get stuck on a problem, do a what if. What if these numbers were a little bit simpler and you could deal with them? Well, this would be the same as saying 2/3 divided by 5/6. Well, notice that my numerator and my denominator are simplified as far as they can before I do that division. All right, so over here, I'm going to have to be sure that my numerator and my denominator are simplified as far as they can before I start doing the division. All right, so let's do that. So 1 over x plus 1, that's my numerator. How can I simplify that? Well, can I just add them together and say 2 over x? No! Would you be allowed to do that if those were fractions? Would you just take 2/3 plus 1 and call it 3/3 and be done with it? No, that's not the rule. You don't just add numbers in there. Remember how simple fractions work so that you can do the fractions with the algebra. And I'm probably preaching to the choir, and I know you guys know how to do this, but when you're stressed about the test, you need to remember how to do the simple math so that you can come back and do it with the algebra. All right, so the rule is find a common denominator. 1, remember 1 can be anything as long as it's the same numerator and denominator. What denominator do we want? X. So we can simplify this to be 1 over x plus x over x. Add those together. Now we follow the rule. The rule is add the numerators, keep the same denominator. We're left with 1 plus x over x. Not x squared, just x. You keep the denominator. Okay, remember your original rules. So there's our new numerator. We're going to simplify our denominator, which is 1 over x minus 1. Same principle applies here. We need to find a common denominator, so 1 over x minus x over x. I just converted 1 to be the same numerator and denominator. What's the basic rule? When you have common denominators, you keep the denominator and subtract the numerators. Okay, so there's our new, this is our new denominator, new numerator. This is our new denominator, so let me write it. Remember the family, 1 plus x over x divided by 1 minus x over x. Now, this is where I want you to simplify it as if it was just a very simple complex fraction. Let's write it the old-fashioned way. 1 plus x over x divided by, remember that symbol? Divided by 1 minus x over x. All right, what do we do now? We just start canceling things out. No, we can't. You recall that you can't divide fractions. We have to really multiply by the reciprocal. So before we can do anything, we're going to have to switch this second term to its reciprocal. Okay, so 1 plus x over x times x over 1 minus x. All right, now can we cancel a few things? Sure, now it looks really nice. We have a numerator and denominator that match, this x and this x. Okay, now what can we do with x plus 1 and 1 minus x? Well, I kept those parentheses around it, so what happens? It's a family. Can't break up a family. The only thing that's going to cancel out one family is if it matches. If I had 2 plus x over 2 plus x, those two families could wipe each other out. That's not a problem. Well, at least in the math world. Okay, so we come over here. These do not look exactly alike. So what are we left with? 1 plus x over 1 minus x. That's it. That's the best you can do until you know what x is. So let's look over here at our answers. 1 plus x over 1 minus x. Look at B, 1 minus x over 1 plus x. They're playing with your mind here, okay? If you rush the problem, then you might get messed up with the addition and subtraction. So be sure that you match it up, that the numerator's addition, the denominator's subtraction. So the answer is A. Okay? All right. We're going to look at problem 6 now in the Algebra 2, sample items. Expand x plus y to the 4th power. All right, if we expand x plus y to the 4th power, I'm going to switch to blue just to mix it up a little bit. All right. Well, you're going to tell yourself, I'm going to take x plus y, and I'm going to take that 4, and I'm just going to distribute it in, right? And I'm going to be left with x plus 4 times plus y to the 4th. No, 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 bad you. Don't do that. You're not allowed to do that. Nowhere are you allowed to do that. The only time you can do that is if that addition and subtraction is not there, okay? You can't just distribute in an exponent. They're trying to suck you in. Look at that. Look at look at letter A. There's the lollipop answer right there. Lollipop, lollipop, oh, lollipop, lollipop. Okay? Don't get sucked in by that. Remember your rules. If you had, if you're not sure what those rules are, put in actual numbers. How would you deal with it if they were actual numbers? Are they going to work out? Okay. A was a trick. Okay. Now what are we going to do? Well, the 4, it looks like they were trying to do some sort of expansion with B. And, of course, it keeps getting longer with C and D. So now what are we going to do? Well, you have to remember what exponents mean. It means x plus y times itself 4 times. Oh, my gosh, we're going to be here forever. Well, it would probably take you a good 5 or 6 minutes to do this problem. If you did it this way, you'd have to FOIL and get that distributive answer. Then you'd have to FOIL it into the third one, and then FOIL it into the fourth one, and hope that you didn't mix up any of your common like terms. Or you can remember something very, very simple, okay? A triangle. Remember those triangles, Algebra 2 people, from geometry? Specific triangle, Pascal's triangle. Starts with the 1 at the top. 1, 1, 1, and then you add the two center terms. 2, 1. Is this ringing a bell? 1, 3, 3, 1. 1, 4, 6, 4, 1. What is this representing? This is representing when you have a binomial and you're expanding it. This is when the exponent is 0, this row of the triangle. This represents when the exponent is 1, and that would make sense. This represents when the exponent is 2. This represents when the exponent is 3, and this represents when the exponent is 4. What does it represent? Well, hopefully you remember, and this is actually a very easy problem. If there's a harder one that comes up, I'll show you how to do the whole expansion with it, or I'll come back to it. But these numbers right here in the Pascal's triangle represent the coefficients, the leading coefficients in front of the variables, okay? Well, if I match it up, 1, this has a coefficient of 1, 4, 6, 4, 1. Now, that's the only one that matched up. So we're going to go with that. But the other piece that you want to look for is that the leading variable, in this case the x, descends as it goes down the pattern. And this is the shortcut. There's certainly a little bit more to it if you don't remember the pattern. But so notice how it's x to the 4, x to the 3, x to the 2, x to the 1, x to the 0, which would be 1, so there's no need to write it. And our second variable would have to go the other direction, ascend, if you will. And I always start at the far side. See x to the 4, x to the 3. I'm sorry, y. Y to the 4, y to the 3, y to the 2, y to the 1, and then y to the 0. Okay? So if they had, say C had had the 6 the term that had the 6 coefficient in it, you want to be sure that your variables are, in this case, the x is going down, 4, 3, 2, 1, or yeah, 4, 3, 2, 1, 0, and the y's are going up, 0, 1, 2, 3, 4. Okay? This is a very, very powerful tool. Now, it took me a long time to do it because I'm sitting here talking and gabbing to you and trying to explain through it. But it's certainly, just to draw this triangle, see that this was the 4th row, and match my coefficients, this problem's done in less than a minute, okay? Remember Pascal's triangle. Okay, all right. Let's look at another one. Matrix G Matrix G shows the gallons of milk sold at a dairy over a 2-week period. Matrix D shows the dollar amount per gallon. Okay, so this first week 1, they sold whole milk, low-fat milk, skim milk. Week 2, they sold the same kind of milk. And then over here, in Matrix D, whole milk, the revenues, it cost $2.89 for a single gallon of whole milk, and they put in advertising of 29 cents, okay, and then they broke that down again for low-fat and skim milk. If matrix P is the product of G times D, which element in matrix P, so our final answer matrix, represents the total advertising fees for week 1? Well, I guess you could put this into the calculator and come up with your final matrix, but if you don't know what that matrix is representing, it's not going to help you, okay, because you're going to get a lot of numbers. You'll get the values for, in this case, P sub 1, 1, P sub 1, 2. Okay, you'll get those values, but if you don't sure what those represent. So what you have to remember is what is multiplication of matrices represent. Okay, so let me write these two next to each other. And I'm going to leave out all the labels for right now. So 181 times 194, 450, 530, 102, and 127. And that's matrix G. And we're going to multiply that times matrix D, which is 289, 279, 269, and then 29 cents, 32 cents, 35 cents. Okay? Now, when you multiply to create the new matrix, which is a 2 by 2, and where's that coming from? Well, this first matrix G happens to be a 2 by 3 matrix. And matrix D happens to be a 3 by 2 matrix. How do we know we can multiply those together? Just as a quick reminder, if we are going to multiply them together, it's legal because those 3's match. The inner values of the dimensions have to match. What is our answer matrix going to be? Our answer matrix is going to be the external values of the dimensions. Okay? So our final answer is going to be a 2 by 2. Sure enough, that's what they're showing us. Well, I'm just going to show you one. If you were to do this by hand, which I know a lot of you would do it by the calculator, but you were taught it probably by hand at first, you're basically going to take this first row right here. So this represents week 1. And you would multiply it times this first column right here. And that would be, in this case, week 1 times the dollar revenue amount. And that's what's going to end up in position P11. Okay? Oh, let me scoot up so you can see that. That's what's going to go into P11. Okay? Then I'm going to take that same value, I'm kind of circling it in green now, and I'm going to multiply it times the second column. And that's week 1 of all the milk and how much was spent on advertising fee. And that's what's going to go into P12. Okay? Then I'm going to take this bottom row and multiply it times this first column. And that's what goes into P sub 21. And then let's see if I can find another color. Ooh, neon green. Then I'm going to take this second row again and multiply it times the last column, and that's going to be P sub 2. Okay? So now that we have the values, this was representing week 2 revenues, all week 2's advertising fees. All right, so what's the question now that we've kind of analyzed what it does? What are the advertising fees for week 1? Here's week 1 times all the advertising. That was this first green one, P12. Okay, P sub 12, which is choice C. Okay, so oops. So it's great that you understand how to type it into the calculator, but you need to remember what these values mean, especially if it's something like this. Getting the answer wasn't going to help you. They didn't ask you what was the total advertising fee. Now, if they did, I would certainly expect you to type this into the calculator real quick, do this multiplication. If in your calculator you had multiplied matrix D times matrix G, it would come up with an error because the dimensions don't work. Okay, so don't panic, just switch it and look at your values there. Remember the basics. Okay? All right, awesome. All right, let's look at the next one. Okay, we're going to be looking at goal 2. And, woo! Get my paper over here. And I have some answers up here, but goal 2, some of these objectives, I'm not going to show it to you, I'm just going to read it to you. Using the composition and inverse of functions to model and solve problems. Use quadratic functions and inequalities to model and solve problems. Use exponential functions to model and solve problems. Whoop, did you peek? Create and use best fit mathematical models of linear, exponential, quadratic functions. Okay, so this is probably the gut of the course that you for Algebra 2, isn't it? Rational equations, cubic equations. These were all the functions and equations that you've been dealing with most of the year, okay? Now, the nice part about this is that a lot of this can be done on the calculator. That being said, even though you can do it on the calculator, you have to know what it means, okay? So as we go through this, I'm going to try to find ways for you to shortcut the problem and get the answer on the calculator if need be. And then I'm going to find, and then if we have to work it out long ways or you get yourself in trouble, we'll figure out what works, okay? All right, let's look at the first one. First one says, if f at x equals x squared minus x and g at x equals x minus 1, what is f at g at x? Okay? Now, I know you remember what this means, but just real quick. If I said g of x was 1, okay, just a 1, then I would replace everywhere I see the g of x in this composite function, g of x becomes 1, so now I really want to know what is the value of the f function at 1. So this is just a quick way of doing a type of substitution. Okay, do you remember that? This early on in the year you did stuff like this. And you actually probably should have been doing it all year, but you might have looked slightly different. Okay, if I had said g of x is equal to happy face, then everywhere in the g of x I would put a happy face. So I would say, okay, what is f at happy face? Okay, it's just a direct substitution of the value of g of x being substituted into f. Okay, all right, so our functions were f of x is equal to x squared minus x, and g of x is equal to x minus 1. So what is f at g at x? And sometimes I write the one that's inside the parentheses a little smaller. Okay, so what is g of x? Well, let's go ahead and replace it. So I really want to know what is f at x minus 1, which means everywhere in the original f function, I want to substitute all my original x's in the f function with x minus 1. Okay, so let me change colors just so we can see the difference. All right, so here's an x squared. So it's going to be x minus 1 squared minus x minus 1, and that represents that x. And I'm going to put a parenthesis around it, keep the family, because we never know what's going to happen, okay? All right, so now we need to go ahead and simplify this to figure out what the value of f at g of x is. So we need to square this. Are we going to take that exponent and pull it in? No, we're not. This is FOIL method. So this means x minus 1 times x minus 1. All right, let's deal with this little part first. And you certainly have been doing this long enough. So x squared minus 2x plus 1. So that's the first part simplified. Minus x minus 1. Those parentheses are there not only to protect the family, but see how this is like a little missile out here trying to get in? You can't just remove those parentheses and combine everything, okay? Again, what is that? That's that evil negative 1 hovering around there. So what we can do is you can think of it a couple different ways. And this is what I probably should have done at the very beginning, which is why I was thinking ahead. If I change this to plus a negative 1, then that reminds me that I need to distribute that negative in, okay? And that's what I kept trying to do in that first problem, but I wasn't saying it. I just kept messing up my sign. So distribute in that negative, so that leaves me with negative x, and then negative 1 times negative 1 is positive 1. Okay, now combine similar terms. X squared, there's no other x squared terms, so we're good to go there. Negative 2x and a negative x, that leaves me with negative 3x. See how I'm underlining them? Think I'm doing that for your benefit? No, I'm doing that for my benefit. Try to keep organized, see what matches, just underline them, and then I lightly cross them off so I know that I've gotten all the like terms in the problem. So there's a plus 1 and a plus 1, which is a total of a plus 2. So the value of f at g at x is x squared minus 3x plus 2. Now what's so nice about this is now, if this had been a function or this is an example, because this is a parabola, right? Maybe it's the football player throwing the ball, and then there's the g of x might have been the wind speed or something. Who knows what's going on? This is a combination of two effects, and this is the one result. So you can substitute in values very quickly now to get your answer. Okay? But that's not what they're looking for. They just want to know what is it equal to. And if we match our answer, x squared, they all start with x squared, so minus 3x, so that it quickly eliminates those, and then ends up with plus 2. There we go. C. Nice, huh? I like those. That was one of my favorite sections when we did functions. All right, number 2. A car insurance company has a special plan for safe drivers. Please be a safe driver, okay? When you start paying your own insurance, you're going to become an even more safe driver, okay? But be safe. Has a special plan for safe drivers. For each year that a driver has no tickets or no violations, the premium is reduced by 10%, and a credit of $15 is awarded. Which equation shows the amount a driver with no tickets and no violations owes in the n plus 1th year, so we're not quite sure how far down the line it is, as a function of the amount owed in the nth year? Well, the nth year would be, say, the first year, or the year that came before n plus 1th year, okay? So this is a function. They told us a function. That's that notation. So f at n plus 1. So all of that's the same. So we're looking at our answers, kind of analyze our answers would be the easiest way to do this problem. And they want to know, you have your original amount from the nth year, so f at n, and then what did they say happened? Well, if you didn't have any accident or any violations or any tickets, you're going to reduce your premium by 10%, and then you're going to get a credit of $15. So here, reduce by 10%, 0.10, right, of the original F at N. This is add 10%, so we can say B is out. This is add 10%, so we see B is out. So now our choices are left with A and D. Okay? All right, so we have our original amount of money. Let's pay, maybe you're spending $500 on insurance, minus 10% of that $500, so you got a little bit more off. And now you have a credit of $15. Credit of $15. Well, we have to choose whether it's subtract 15 or add 15. A lot of times when you think credit, thinking, oh, I got some money, I got some credits, okay? It's not like a video arcade where you get credits and you earn credits and you get your tickets and you get your prize or whatever it might be, okay, or you get the high score. When you're getting credit towards a bill, like if you took something and returned it, get credit towards a bill, they're actually putting money back onto the account. So they're subtracting it from the total amount you paid, okay? And that's very tricky because a lot of times we think credit, where was the word in here? Premium, a credit, a lot of times we think credit is getting money, okay? Don't be fooled. If somebody gives you a credit card and they say you have $5,000 on that credit card, you don't have $5,000, okay? You can borrow $5,000, so really that's a negative amount that you're taking away, right? All right, so with that in mind, we look at A, okay? So this one you didn't have to do a lot of mathematics. You simply had to analyze your answers and keep eliminating. But what did you have to understand? You had to understand the vocabulary, okay? So this is a real-world situation. These are the type of questions that are going to come up. It is acceptable that you would understand what car insurance might mean at this point. If not, let it be any insurance. Let it be anything that you pay for a special plan. Maybe you bought an insurance policy on a TV at Circuit City or something, or maybe, I don't know, but think of different things where you might pay a certain amount, and then if you're really good at what you're doing, you get extra money back, okay? So don't panic if you don't know what car insurance is or how this works, okay? Just follow the patterns. All right. Gary from Nightdale High School said, can we please skip and go to number 4? Yes, Gary, I will do that for you. Okay? All right, let's look at number 4. Look at that. Let's look at that. All right, I got my papers. Hold on, see? I had to go to number 3. Look at that logic going in my head right now. All right, so if we look at this problem, if 3 plus 2i is a solution for x squared plus mx plus n equals 0, where m and n are real numbers, what is the value of mn? Okay? So the way I would set this up is you need to think about, first of all, what are some of these values? If 3 plus 2i is a solution, so solutions are like when you factor it, right? So kind of think in the future, if you were to factor, if you knew what m and n were, you could factor them. Or real numbers, what is the value of m? So what I would do is I would say, okay, x minus 3 plus 2i times x minus 3 minus 2i, okay? And that's going to help me figure out what those two factors are. Now I'm just going to do some long division here, okay? So if we multiply it out, x times x is x squared. I'm going to FOIL it. X times negative 3 minus 2i will boil down to, oh my goodness, minus 3x plus 2xi. Okay. I don't think I'm going to explain this to you very well. So x squared minus 3x plus 2xy, if I go through and do the FOILing, okay? So if we look at our original value, we have x squared plus mx plus n equals 0. What we need to do is figure out what are these values to make this work. Well, see the m here, the 3? No, that's not it either. Gary, you're going to have to give me a second. Oh, I have to keep multiplying out. Let's keep going, right? So we have to do the whole FOIL method. Okay, so I did the x times x. I did the x times the negative 3i2. Let's keep going. So 3 times x will leave me with negative 3x minus 9 minus 6i, if I do the FOIL on those two. And now this last piece, 3 plus 2i and 3 minus 2i, those are conjugates, so we'll multiply those out, and we'll get 2, no. Gary, I'm going to call you back. Mess myself up here. No, there we go. We're set. I add these together. Oh, my goodness. All right, so x squared, those become minus 6x plus 2xi. So 2xi plus a minus 6i, because we're not quite sure what that x is, right? Kind of go together, and a minus 9. So our question is what does the x value have to be? This mx? There it is, your 6. I did not explain that very well to you. I might try that again here in a second. Moral to the story. Okay. I was trying to shortcut it for you, and I shouldn't have done it. I should just outlined it all out for you. You basically are doing long multiplication and doing, the hard part is you have to kind of think about, this is just an extra term like if it had been x minus y or x minus 2. So you do that long division, then combine your similar terms, and then you're not really trying to solve. You're just trying to see what matches up, like that problem we did before. What matches up? There's the x squared matches up. There's the x term. What matches with the x term? The m. That would be the negative 6. All right, call back if that didn't make sense, and I'll try that one again for you, Gary. All right? Sorry about that. Pardon? The most important part is if, here, let me just double check some of my notes. If 3 plus 2i is a solution, so is 3 minus 2i, okay? 3 minus 2i, or 3 plus 2i, the other solution has to be 3 minus 2i, okay? In the imaginary world, because when you found it, you did a square root at some point, and you got these values, remember? Not explaining that well to you. We'll come back to that one. Sorry, Gary. Hope that helped a little bit. You have to remember that you have both solutions, so we had to deal with both solutions there, okay? All right. Let's look at number 3. I'm going to back up again. All right. A company found that its monthly profit P was given by P equals negative x squared plus 120x minus 150, where x is the selling price for each unit of the product. Which of the following is the best estimate of the maximum price per unit that a company can charge without losing money? All right. The very first thing that triggers in my mind when I see this is I see that I have a quadratic. If I analyze the quadratic a little bit, I see that the a term is negative, so I know it's going to be a frowny face parabola, right? Which means, oh, it would have a maximum, and they asked for a maximum. Oh, so you know what I'm going to do? I'm just going to type this into the calculator and find the maximum. All right, so let's do that. Let's go over to the calculator. Y equals, let me clear out some of my other stuff. So y equals negative 10 x squared plus 120x minus 150. Okay. If I graph that, whoo, it's way up there. So let's zoom to fit a little bit. See if that'll help us. There it is. Still a little bit over, but you can, if you look at the screen, you can see that there's a, let me come back to my Elmo real quick. All right, if you look up here, you see how it arched up? I might bring this window out a little bit, but there's a maximum point up there. Well, you know what, even if we can't see it, let me go back to the calculator. Let me change my window just a little bit, and we'll make it, looking at the graph, we want to see a little bit higher into the x, right? So let's make this, negative 10 was fine, but let's make this maybe 50. Let's see if that helps us out a little bit. Whoop, there it is a little bit, okay. So, oh, and we'll get a little bit higher on the y, too. I went a little bit over, so let's go a little higher on the y. Let's make this, I don't know, 400. Let's see if that helps. There we go. All right. So we have an awful lot of the bottom part of the screen. So if we come back over, look at your screen. I know this is hard to see on here, but if we look at the very tip of the top, there's our maximum point, right? What is that point? Well, you could type along and see if you could find it, but no, you're going to use the functions that are in your calculator. So if you go back to the calculator at the very top, one of the choices is calc, so second trace, which is calc. We're going to calculate the maximum value, and it's going to ask for the left bound, so the left side of the graph. So arrow over, and you don't have to know exactly when it hit the left side, just somewhere on the left side, okay? Enter, and now it's asking for the right boundary, just somewhere on the right side of what you visually see to be the maximum point. Enter, and now it's asking you, do you want me to guess? Yes, guess, that's why I'm asking you. And it guessed that the maximum point was x was about 6 and y was, let me write that down, x equals about 6, and y equals 210. And look at that, that's choice B. You found it, right? Nah, didn't find it. Okay? This is one of those problems that you need to read it just a little bit more careful, okay? You saw a parabola, you see the word maximum, and you shoot for the maximum, and you've got an answer. And the calculator certainly found it for you very quickly. But that's not what it's asking you. It's asking you for the best, darn it, that's twice, estimate of the maximum price per unit that the company can charge without losing money. When would you know you start losing money? Okay? Well, P is the profit. That we could also, let's just change that to a Y. If our Y goes into the negative, then we start losing money, right? All right, so this isn't asking for the maximum value, 6 to 10. It's asking you for the maximum value before we start losing money, all right? So to find that, let's look at our table real quick, okay? So go back over to your calculator, look at your table, and at what point, and if you look at some of your choices there, you have, what point does the Y start losing money, right? Look at that. I go down in the table. See, I was still making money at 8. Let me go back up to the top. You can't be looking at -1, -2, -3. You can't be looking at your x values being negative because that wouldn't be true data. What I'm trying to think, it's like you're paying someone to buy your chair. Okay, if you're selling the item, you're not going to start paying people to buy it. Okay, so that's not the side we're looking at. We're starting at 0 to move forward. And we start losing money at, look, see at 11? -40. So 11 is what we're looking for, which is choice C, okay? So take a second, read the problem, read it twice, live on the edge, and read it 3 times, okay? This is not a novel from Language Arts. This isn't even like the tests that you take that have reading comprehension where it's, you know, a whole page of reading. It's a little tiny paragraph, but it has a lot of important words in there, okay? All right, good. Don't forget. Promise? I know you're answering me. I can see you nodding. All right, let's look at number 5. James purchased a truck for $25,900. Nice deal, depending on the truck, I guess. The value of the truck decreases by 12% each year. What will be the approximate value? The approximate value be 8 years after the purchase. Okay. All right. Well, if he purchases a truck, let's is just year 0. Okay. Year 0, he buys a truck for $25,900. The following year, it decreased by 12%. So what you could do is you could say, okay, what is 12% of $25,900? Then subtract that from the $2,500. But if it decreases by 12%, then isn't it really only worth 88%? Okay, so we could say that year 1, after you've owned the car a year, it's 0.88, which is 88%, times the value of the car the year before. Okay, so this is year 1, and this is representing the original year that you bought the car. Okay, so whatever that answer is, so year 2 would be equal to 0.88 times what? Times year 1. Okay. All right, so let's start doing some of this. So I'm going to pop over to the calculator now. Actually, we're going to end up doing this how many times? 8 years. Okay. So if you can keep track, you're really just taking the answer that's in the calculator and multiplying it times 0.88 over and over again. I sometimes lose track, so I'm just going to keep a record of it. Okay, so let's quit out of what we're doing. So over here on the calculator, I have 0.88 times 25900 is equal to, the second year the car was worth $20,792. Okay, the second year is, again, it's worth 88% of whatever it was worth after 1 year, which is $22,799. So I'm going to take my answer. If I go back over to the calculator, I'm going to take that value, the answer, which was $22,792, times 0.88 is equal to, all right, the second year it's worth $20,056.96. All right, year 3. Year 3 is, it's worth 88% of whatever it was worth after 2 years, which was $20,056.96. So over in the calculator, all I have to do is say times, because it's going to take the answer from before, times 0.88. So now In year 3, it's worth $17,650, and I'll round. Now the calculator, just because I'm hitting answer, I won't have to round in the calculator, so I just write it all up here. Okay, so year 4 is equal to 88. You lost 12% of it, so it's worth 88% times what it was after 3 years. So again, on our calculator, answer times 0.88 is equal to year 4, 15,532, 10982. Now, of course, if we were actually looking at this would be money, we'd start rounding and see our answers here over on the paper or on whole numbers. But since I'm just letting the calculator take the number, I'll just keep writing it for you. So year 5 is equal to, well, it's worth 88% of whatever it was after 4 years. So over to the calculator, times 0.88, enter. So now it's down to 13,668, and I'll look at all these pennies. But you know what? Banks collect those pennies, even those 10/100ths of a penny. And if you have 10,000 people and 10/100ths of a penny, that does add up after a while, so don't neglect those, okay? So she's like, that was so random. Okay, it won't be random when you're paying your car loan, will it? So 0.88, again, it's worth 88% of year 5, which equals answer times 0.88, enter, 12,028.06585. Just let the calculator hold that answer for you. Year 7 is worth 88% of whatever happened from year 6. Answer times 0.88, enter, 10584, 10,584 and about 70 cents. Okay, look at that. Just after 7 years, half its value, a little more than half its value, right? Where did it go half? It went half at about year 6. And finally, year 8 is equal to 88% worth of whatever was left over at year 7. So times, back on our calculator, the answer times 0.88 is equal to $9,314 and 534192. And if looking at our answers, they're rounding to the nearest 100. So this would be 9,300. And sure enough, that's answer C. Okay. Now, so how can this help you? Well, this might be how they calculate, some of the values in your area of what cars are worth. So this is a real life problem that you would actually do if you wanted to calculate what your car might be worth in a certain time. You don't have a blue book value. Somebody tells you how much it decreases. Okay, so it's good to know. All right, let's look at number 6. Okay, Lisa from East Wake High School has called, and I'm going to skip to number 7. Okay, let's see if I can do you better than I did with Gary. I got all flustered, didn't I? All right, so let's look at number 7. And actually, number 6 is a good one to help you with number 7 because they use the same formula. Let's go ahead and do number 7 first. The equation, C equals 523,430 times 1.93 raised to the T, models the pounds of U.S. copper produced from 1987 to 1992. Wow. Which statement best interprets the coefficient and the base of this equation? Well, let me rewrite it over here. C equals 523,430 times to the T. Okay, first of all, what's the coefficient? And what is the base? Okay, well, the base is the base of an exponent. So here's our base over here. And then coefficient is the value that comes before the variable. That's a good way of looking at it, I guess. All right, so they want to know what is the 523,430. What does that value represent? And what does the 1.193 represent? Okay, and we know T is representing time. How do you know that? Well, there's a formula you need to remember. A equals P, the original principal, times 1 plus the rate, raised to time, I guess, since that's what we're using. Okay, so there's a couple things happening in here. 1 plus the rate, that's going to help us with that base, and then P, that was our original value, right? So we want to say it was the copper production in 1987. This was the value in 1987, and that happens all the way along. Copper production Oh, see, this one increased by a factor. Increased by a factor. I don't think so. That's just the original value, right? The copper production at the beginning of 1987 was 1.193 pounds. That doesn't even make sense. Looking at this, models the pounds. You have to remember the formula to know what that represents. So the value inside the parentheses is representing some sort of rate, in this case, an increase, right? And the 523,430 is representing that original value in 1987. Okay, so the only one that is dealing with that is A and B. Those are the original values. So let's see what those. C is definitely out, and copper production, no. 1.193 pounds. That wouldn't even make sense. That the only amount of copper, 1.193, like 1.2 pounds of copper. I think we did a little bit better than that. Just look at your pennies, right? Those weigh more in the bottom of your purse or your pocket, right? All right, so what is this? Well, you have to remember this formula because this rate, see how they're trying to trick you up here, is 1.93%. No, what it's really representing is the 1 plus some value, right? Well, 1 plus 0.193. Okay, well, 1.193 is not our choice. Well, we have to change that to a percent, right? So 0.193 as a percent would be 19.3%. And there it is, part B. Okay? So the key to this was not whether you knew anything about U.S. copper production. What it had to do is if you understood what this original formula was, okay? So your final value is equal to your original principal, 1 plus the rate, because it was a rate increase, exponent of time. And you would have seen that also with, remember PERT? You had problems when you were dealing with continuous continuous interest over time, things like that. Okay, these are the same type problems. All right. We have another specific question, or? All right, let's look back at problem 6. Lisa, I hope that helped you out. Oh, all right, let's look at number 6. The Wongs bought a new house 3 years ago for $92,000. The house is now worth, after 3 years, is now worth $113,000. Assuming the steady annual percentage growth rate, approximately what was the yearly rate of appreciation? To be honest, this is a common sense problem. Now, I'm not sure how many of you out there in Algebra 2 own a house, okay? So I won't, if you don't know the logic behind it, I won't be upset with that, but think about it. From 92,000 to 113,000, would that have been an increase of 61%? Over half? No, that's an awful lot. That means you would have taken half of the 92 and added to it, plus a little bit more, because we're talking 61, we're not even talking 50%. So 61 isn't even a viable answer for us to deal with. And to be realistic, 22.8 is not really a viable answer. And if you really want me to analyze it, A is the only viable answer. But let's pretend you don't know that. Oh, let me push it over. You can't even see that, can you? There we go. All right, sorry about that. All right, so how would we do it mathematically? We needed to use the same formula that I mentioned before. A is equal to P times 1 plus R to the N, and substitute in our values. The final value of the house in this case was 113,000 is equal to the original value, 92,000, times 1 plus the rate. Well, the rate is what we're trying to find, so we're going to solve for R, and it was over a 3-year period of time. How would we solve that? We're going to divide both sides by 92,000, and we'll be left with 1.2283 is equal to 1 plus R to the third power. How do we solve that? We're going to take the cube root of both sides. The only way to eliminate something raised to the third power is to take the cube root of it. The calculator, you can type that in. I don't know if you know where that is on your calculator, under the math button. If you look over in the calculator under the math button, there's fraction, decimal, raise something to the third power, take the cube root of something. And then the fifth one, number choice 5, is to take the nth root. You can put any number in there. All right, so if we take the cube root, that would be approximately 1.071 is equal to 1 plus R. Cube root of something cubed is what's under there, right? Go ahead and subtract 1 from both sides. We're left with 0.071 is equal to the rate. Looking at our answers, they're in percent form. So how do you change that decimal to percent? Move the decimal twice to the right. So you're left with 7.1% is equal to the rate, which is choice A. So logically that makes sense, especially if you own a house and you know how the values increase. But if you don't, mathematically it's a very simple problem for you to work out. All right. Well, that's all the time we have for today. Good luck on your exams. I know you all are going to do wonderful. We're going to be back next semester on Wednesday nights to accept your calls as you go through the semester. You can call in for algebra, geometry, and algebra 2 problems anytime. So watch for that to show up on Wednesday nights. Okay? All right. We'll see you then. Bye-bye.